titanium, and tungsten are some of the strongest metals on the planet. But which one is stronger? The answer, as you're about to find out, is a case of oranges and apples. We first need to define what we mean by strong. High tensile strength? More resistant to scratching or wear and tear? Won't crack when hit hard? A strong material is one that, according to materials science, resists both deformation and failure. Materials react to external forces in different ways before deforming or breaking. They may be ductile, which means they can deform without losing toughness, or they can be brittle, which means they shatter easily under stress. Materials can also be defined as strong based on their hardness. This is the ability of a material to resist denting, scratching, or other permanent changes when under compressive force. For the purpose of this video, we'll rank the two based on their scratch resistance, brittleness, ductility, tensile strength. It is also important to note that it is rare to use pure metals for most applications. Both tungsten and titanium are usually alloyed with other metals to make them more workable. Tungsten, for example, may be combined with carbide to make tungsten carbide. Titanium is often alloyed with metals like aluminum or vanadium. Titanium alloys are graded based on their properties. For example, grade 5, often called the workhorse grade, is the most commercially available titanium alloy. It offers an excellent combination of high strength and toughness and has good welding and fabrication characteristics. So with that out of the way, let's see which of the metals is the stronger of the two. When it comes to either material's resistance to scratching, the answer is a no-brainer. The tungsten alloy tungsten carbide is hands down the most resistant to scratch damage when compared to equivalent grades of titanium alloys. In fact, it has a hardness not too dissimilar to diamond. Hardness of a material is measured on the Mohs scale of hardness, developed by the German geologist Friedrich Mohs in 1812. It is one of several scales of hardness used in materials science. The Mohs scale ranks materials on a scale of 1 to 10. Materials like talc have a Mohs hardness of 1, while diamond has a Mohs hardness of 10. On this scale, most commonly used tungsten carbide alloys have a hardness of 8 to 9 on the Mohs scale. Equivalent titanium grades, on the other hand, come in at a Mohs hardness of 6, which is just less than quartz at 7. For this reason, tungsten carbide alloys that are equivalent to titanium grade 1 are also the most scratch resistant of the two materials. If you wanted to, you could easily scratch titanium with tungsten carbide. However, both are still considerably more scratch resistant than softer metals like gold and silver. But a material's resistance to scratching is only part of the story. For some applications, metals must also resist cracking, shattering, or other types of impact damage. More technically, this is called brittleness. And here again, there is a clear winner between the two. Titanium is much better at resisting cracking than tungsten. This is because titanium is a lot more ductile in general and tends to deform rather than shatter under impact stress. This means tungsten carbide cracks with less force than equivalent titanium alloys. As titanium tends to deform when put under stress, it is more likely to bend than tungsten carbide. Tungsten carbide, on the other hand, will resist tension up to a point and then catastrophically break or shatter. One common way to measure this is called ultimate tensile strength, which is measured in megapascals. So which is stronger? That depends on how you define strength. Comparing the two is a bit like comparing oranges and apples. They are fundamentally different materials used for different purposes because of their physical properties. Need a very hard metal that can resist scratching or deformation under stress? Choose tungsten. Need a lightweight, corrosion-resistant material that will deform rather than snap if placed under pressure? Perhaps for use in a bulletproof vest? Then titanium is your best choice. Though if you do choose titanium for armor, make sure you are not being shot at by tungsten bullets. Chances are they will penetrate.